Welcome to the video lecture series on Advanced Separation Process. Myself, Jaimin Pandya, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In this lecture, I will briefly introduce to the advanced separation process and give brief overview of the subject. According to syllabus, there are mainly 7 chapters. Chapter 1, which is fundamentals of separation process. In this chapter, we'll talk about the various principles of separation process. Then we'll talk about the separation factor, chemical potential in interface mass transfer, equilibrium and rate governing separation process, drawback of conventional separation process, and need for advanced separation process. And we'll talk about major areas and application of advanced separation process. So in this chapter, we'll talk about the various basic fundamental of separation process. We know that in chemical industry, after the reaction occurs in reactor, it's required to separate product and unreacted reactant. For that, separation process are required. There are various separation process such as distillation, liquid-liquid extraction, crystallization, osmosis, forward osmosis, reverse osmosis, various membrane separation processes. So these all separation process are required to separate reactant and unreacted reactant and product. Separation processes categorized on basis of principle of separation. There are mainly two bases of separation process such as equilibrium governing process and rate governing process. Equilibrium governing process, which means one phase is equilibrium with second phase. After achieving equilibrium, that phase is easily separated using purpose of the heat and other factor. In distillation column, if there is a two mixture A plus B, now if we want to separate these both component A and B, we have to apply heat to the distillation column. By applying heat and due to the difference in boiling point, separation becomes possible. Let's suppose there is component A which has 100 degree Celsius boiling point and component B which has 200 degree Celsius boiling point. So if we are going to heat that mixture at 110 degrees Celsius, then component A will be achieved from the distillate and component B can easily separate from the residue. If the boiling point of both components are near, we cannot separate that mixture with using distillation column. We need to require some other process such as a liquid-liquid extraction. So in liquid-liquid extraction, what happens? Component A and component B, there is a mixture of these both components, and if we want to separate this component, we require to add third component which is a C. So let's suppose there is a third component is C. Now if I am going to add this component C in this mixture, so this component C is make mixture either from A and either from B. So can say that in other words, component A or component B miscible with in component C. So either A or either B miscible with a component C. So if we are going to add the component C and let's suppose component A is miscible with that solvent, then it make mixture of component A and C and B will be separated. Now further we have to separate component A and C. For that we have to use distillation. So that can say that liquid-liquid extraction and distillation is a one type of technique in which equilibrium occurs and then separation will be possible. In distillation, by applying means of heat, we can separate the both component and both component are equilibrium by applying of heat in vapor phase and liquid phase. Where in liquid-liquid extraction, both liquid component are in equilibrium when adding the third component C and make the separation possible. So this is one type of equilibrium governing process. Now let's talk about the rate governing process. In rate governing separation process, there is a driving force. Due to that driving force can separate a mixture. So there are various rate governing separation technique such as ultra osmosis, osmosis, then forward osmosis, reverse osmosis. These all techniques are known as a rate governing separation process. There are various driving forces for separating this rate governing separation process such as a pressure, temperature and dialysis. In dialysis, there is a concentration difference, due to that separation becomes possible. In membrane distillation, there is a temperature difference, due to the separation becomes possible. And in reverse osmosis, ultrafiltration, nanofiltration, there is a pressure difference, due to that separation becomes possible. And in osmosis, due to the chemical potential difference, there is a separation becomes possible. So these all are techniques are considered in rate governing separation process. So there are various disadvantages of conventional separation process. That's why it's need for to develop other separation technique which overcome that problem, and that type of technique is known as the advanced separation process. For example, in liquid extraction, we have to add third component and further we have to do distillation, so that cost of that process will increase. If we are going to use the membrane separation process instead of that liquid extraction process, we can overcome the various cost problem related to the liquid extraction process. That's why it's need to develop the advanced separation process. So there are various major area for the advanced separation process such as wastewater treatment and other processes. Now let's talk about the second chapter. In second chapter, we'll talk about the various types of membrane separation process, membrane types, membrane material, synthesis and characterization of membrane, different membrane modules, working principle, operating parameter, membrane used for transport process, mechanism of industrial application for individual membrane process such as reverse osmosis, nanofiltration, ultrafiltration, microfiltration and dialysis. So what is membrane separation process? In membrane separation process, there is one driving force as discussed previous section. Due to that driving force can separate a mixture. So this figure illustrates the membrane separation process. This is one membrane. If we are going to add feed from this side, we get separation of two mixture, component A and component B. Small molecule component can be passed through the membrane and other component retained from the membrane. So component that rejected from the membrane is known as a retentant, and component which passed from the membrane is known as a permeate. So there are various processes for that: reverse osmosis, nanofiltration, ultrafiltration, microfiltration. For this all process, different type of membrane are used. This membrane have a different types of pore size. For example, pore size of reverse osmosis, which is very small compared to the nanofiltration. Similarly, compared to the ultrafiltration, nanofiltration pore size is very small. So in reverse osmosis, water can pass, but other components from the water, such as a various impurity, that can be rejected. Where in nanofiltration, water molecule can pass, ions can pass, and multi-ions can partially pass from the membrane, and other components such as a virus and bacteria are rejected. Where in ultrafiltration, water molecule and other ions and multi-ions can pass, and virus and bacteria can be removed. Where in microfiltration, the bacteria and suspended solid are rejected, and other molecules such as a water molecule, multi-ions, ions and virus can pass from the membrane. So this is the basics of the membrane separation process. Then in chapter 3 we will talk about the membrane gas separation process, fundamental and mechanism of that gas separation process, governing factor, principle of designing of gas separation mechanism using complete mixing model, gas separation membrane application of gas membrane separation. Then we'll talk about the pervaporation process and membrane reactor. In conventional technique, for separation of gas, we require cryogenic distillation. For cryogenic distillation, energy consumption becomes high. That's why we can replace that cryogenic distillation using membrane gas separation process. Then we'll talk about the pervaporation technique, principle of pervaporation, membrane use and application of the pervaporation, hybrid distillation pervaporation system. So what is meaning of hybrid distillation pervaporation system? To understand this, Let's consider one example. Let's consider there is a solution of ethanol plus water mixture. Now if we want to separate this mixture, we require distillation column, and if we are going to separate this mixture with using simple distillation, we cannot achieve good amount of ethanol because it makes azeotrope. But if we are going to replace condenser of that distillation column with per evaporation unit, we can get 99.98% pure amount of ethanol. So we can replace the various process with this per evaporation technique. Then we'll talk about the membrane reactor, concept and working of membrane reactor, various types of membrane used in membrane reactor, and membrane bioreactor. Then we'll talk about the chapter number 4, which is reactive and catalytic distillation. Then we'll talk about the advantage and disadvantage of reactive and catalytic distillation, various types of packing which used in reactive and catalytic distillation, such as bale packing and catmax packing. Then we'll talk about the short part distillation unit. So we'll talk about this type of distillation in advanced separation process. In conventional technique, we require reactor, and then after we have to separate the both component, unreacted reactant and product with distillation. But if we are going to replace this reactor and distillation column with reactive catalytic distillation column, we require only one column. So this problem is overcome by this reactive catalytic distillation column, in which reaction and separation both occurs in one unit. Now if we want to separate a thermal degradable component, we cannot use simple distillation. If a component is thermally sensible, then it will be degraded. For that, if we want to separate that component, we are going to use the short path distillation unit, in which path will sort by the providing internal condenser in distillation column. So we'll talk about this short path distillation and reactive catalytic distillation in this chapter number 4. Then we'll talk about the chapter number 5, which is a supercritical extraction. In liquid-liquid extraction, as discussed in previous section, we require one solvent that separate both either component A or either component B, and then after we have to do distillation. But if we are going to choose supercritical fluid instead of that solvent, then we eliminate distillation portion from liquid-liquid extraction. So this liquid-liquid extraction process is replaced by supercritical extraction process and overcome various problems which related with the liquid-liquid extraction process. So we'll talk about the supercritical extraction, working principle of supercritical extraction, property of supercritical fluid, solubility behavior of that supercritical fluid, advantage of separation and supercritical extraction, various application of supercritical extraction such as a decaffeination of caffeine, Rose process for purification of crude oil, and then we'll talk about the various research and commercial application for the supercritical extraction. Now then we'll talk about chapter number 6, which is chromatographic separation. In this chapter, we'll talk about the principle of chromatographic separation and their operation, chromatographic column ion exchange, chromatography gas filtration, and affinated chromatography separation. There are mainly two types of chromatographic separation are used: thin layer chromatographic separation and column based chromatographic separation. So we'll talk about briefly about the thin layer chromatographic separation process and column based chromatographic separation process in this chapter. Then we'll talk about advantage and disadvantage of chromatographic separation process. Then we'll talk about chapter number 7, in which we'll talk about the electrophoric separation process, principle of electrophoresis, then factor affecting electrophoresis, gel membrane and paper electrophoresis, then application of electrophoresis. So this is all about the basic content which cover in advanced separation process. After completing this subject, you are able to identify approach separation technique for the indent problem. You are able to understand the principle of membrane separation for the various aqueous system. You are able to conceptualize the reactive catalytic distillation, and you are able to recognize the selection criteria between advanced separation technique and conventional separation technique. So these are various course outcome for this subject. I am completing my lecture here. Thank you.